Hello everyone, welcome back to College Algebra. In this video, I will be talking about section 2.7. We'll be discussing inequality, different type of inequality, compound inequality, absolute inequality, and basic linear inequality. Then afterward, if I have time, I will be discussing absolute equation too. Okay, so let's get started. So section 2.7. Okay, 2.7. So the first part of our video today will be about linear inequality. So I'm going to put the first Roman inequality. Right? Linear inequality. Well, what is linear inequality? As you already know and learn how to solve linear equation, a linear equality is kind of the same as linear equation, but instead of using equal sign, we're going to use four different inequality symbol, which is greater than, less than, greater than, equal, or less than, equal. So these are four symbol in these are four linear inequality symbol. It's greater than, less than, greater than equal, and less than equal. Okay. For example, I can give you a quick example. What's a linear inequality look like? I'm going to give you something very simple. For example, I have x greater than 2. Okay, and I say that this is a linear inequality. X greater than 2. What does it mean by x greater than 2? It means all the value of x as long as greater than 2. Okay, and we don't have to solve anything here. We don't have to solve anything here. So because this is very simple. So that is the first example. Or I can give you something like this. 4x minus 5 less than or equal to 7. Okay, this is the typical example of linear inequalities too, and you can solve for this by the same approach as you solve for linear equation. You isolate on the x term, and you isolate on the constant term, then you solve for x. So in this case, in order to solve for x, you're gonna get rid of 5 right here by adding both sides by 5. So if you add in both sides by 5, you have 4x less than equal to 12, right? Both sides by 5, so 7 plus 5, 12. Then you divide both sides by 4, so you have x less than equal 4. Okay, so whatever you have over here, we call this algebraic solution representation. Okay, so this is algebraic solution representation. Okay, it's algebraic way, and there's another way to express solution of linear inequality based on this algebraic expression. We call that graphical expression. So graphical expression, we're gonna draw the number line. Okay, we're gonna draw a number line. So this is 0 right here. Okay, and where's 4? 4 is around right here, so I'm gonna put 4 right here. So we have to understand this solution first. X less than equal to 4. It means what? It means that all value of x as long as it's less than 4 and it can be equal to 4 also. It means at 4 is included, and because it's included, so we're gonna use the dot sign. So I think I'm gonna use the different color right here. Let me see, I can use different color. So it means at 4 we included, okay, we included at 4 at the end point, and you see that because this arrow here, this inequality symbol here is pointed toward the left hand side, so we're gonna set everything to the left hand side of 4. Okay, so this is called graphical representation of the solution. So this is graphical representation of the solution. Okay, so you see that this is the first way to express the solution. This is the second way to express the solution. The first way is whatever you have when you solve linear inequality. And there's another way to express the solution we call the interval notation. So interval notation, we're going to use parentheses and bracket. Okay, parentheses, it mean not included the endpoint, and bracket mean included the endpoint. So over here, because this is negative infinity, this is positive infinity. So based on this graphical representation right here, we can get the interval notation for the solution. So over here, whatever you shed will be the part in interval notation will be the part represented by interval notation. So interval notation is nothing but it's a part we want to take on the number line. Okay, so for negative infinity, we're going to use a parenthesis all the time. Okay, and for 4, so between negative infinity and 4, so for 4 we're gonna use bracket, right? So this is mean from negative infinity to 4. Okay, negative infinity to 4. Negative infinity, we must use parentheses at 4 because we have the dot sign, so we have to use bracket. Okay. So this is interval notation. So every time you solve linear inequality, I always want you to express your answer by using interval notation instead of what other than algebraic expression. We must use interval notation. So remember this: every time we have a negative infinity or positive infinity, we always use the parentheses. Okay, so remark. Okay, remark. Always use parentheses for infinity. Okay, it could be positive infinity, negative infinity, but as long as infinity, you must use parentheses. Okay, so that is how you're gonna solve basic linear inequality. I can give you another example, something harder. Okay, how about something like this? What if I have a negative 2x minus 2 4x plus 1, right? Greater than how about less than, because this is we already have less than. Oh, let's do less than. Let's do less than. So less than x plus 2 x minus 1, for example. Okay, so the way you solve linear inequality is the same as you solve a linear equation. Every time you have parentheses, you just go ahead and distribute it. So you're gonna have negative 2x, so distribute it, give you negative x 8x. You already learned how to solve linear equation already. Minus 2 less than x plus 2x minus 2. Okay, then we combine it and give you negative 10x minus 2 less than 3x minus 2. Oh, let's change this, change a little bit right here. How about 4? Okay, we change it to 4. So 2 times negative 4 is negative 8. Okay, 8. Okay, there you go. Now we're going to subtract both sides by 3, so you have negative 13x. Add both sides by 2 less than equal to negative 6. Okay. Now, in order to get the x, right, you need to get rid of negative 13. So you have to divide both sides by negative 13. So when you solve linear inequality, every time you divide by negative number or multiply by negative, you have to flip the direction of inequality symbol. So you divide by negative 13, so you have to flip this, so it becomes 6 over 13. Okay, 6 over 13. Okay, so this is an algebraic expression of the solution. We can do a graphical representation. So this is 0 right here and 6 over 13 around right here. And because this is greater than, so it's not included. If it is equal, then it included. It's like last time. Remember last time right here, because it's equal, so we include it. So that's why we draw a dot sign over here, because it's not equal. So we're not drawing the dot sign anymore. So we have to use the open circle. Okay, use the open circle at 6 over 13. Then the arrow, you see the direction of this inequality symbol, it pointed toward the right hand side. So we're going to set everything to the right hand side of 6 over 13. Okay. Okay. Now the interval notation will be based on this. So this will be positive infinity here, right? So whatever we said, we're gonna write interval notation for, because we don't want to increase it over 13, so we have to put parentheses 6 over 13. Okay, let me erase this. Okay, comma positive infinity parentheses. Okay, so what I want you to notice over here is that every time, so that's another remark 2, every time you have you divide or multiply by negative number, you have to flip the direction of the inequality symbol. Okay, flip direction of inequality symbol. Okay, every time you multiply or divide negative number. Okay, so remember that. Okay, so that is how you solve linear inequality. Okay, you have to remember this remark and the second remark over here. Okay, now on the second part of our lecture, well, the example I give you over here is the kind of a pretty simple. You know, I can transform it a little bit. You know, I can put a fraction over there if I wanted to. Okay. Okay. On the second part. Okay, on the second part, I will introduce a compound inequality. Okay, what is compound inequality? Well, compound like it's like more than one, right? Like it's like combined, right? So it's nothing but you can combine two or three inequality together. As long as you combine it, then you just create a compound inequality, and we can use these two words right here, the one I'm gonna write now, to combine inequality. The first word is or, and the second word is and. And the symbol for this word is the open up letter U. This is called union, and for N is the upside down letter U. This is called intersection. So we need to understand what union is and what intersection is. Union, it means that you take all the shaded part. Okay, now let me move. Okay, let me move over here. Okay, take all shaded part. Okay, and for intersection, you just take the shaded part that share in common. Just take shaded part that share in common. Okay, so every time you solve compound inequality, after you get the algebraic expression of the solution, you should draw the number line. You should graph it, and when you graph it, you can get the final solution, because sometimes whatever you solve in each inequality is not the final solution yet. Okay, for example, let me see. I can give you something. Okay, for example, I have something like this. I have two inequality. The first one is 6x minus 4 less than 2x, and I combine with another inequality using the word or. Okay, so without or and, then it's not compound inequality anymore. Okay, I have a negative 3x over here less than equal to 9, negative 9. Alright, so I just created a compound inequality. So the way you solve compound inequality, which is just go ahead and solve individually, one by one. So I'm going to go ahead and solve this first. I'm going to subtract both sides by 2x, so which is give you 4x minus 4 less than 0. Then I add both sides by 4, so I have 4x less than 4 and x less than 1. Okay, and over here I divide both sides by negative 3. So when you divide by negative 3, you flip the direction of the symbol, right? So it will be x greater than negative 3 divided by negative 9 divided by negative 3 will be 3. Okay. So after you have your after you already solve the algebraic solution, it's good that you go ahead and express it on the number line. Okay, so on the number line. Okay, so you have 0 right over here, you have 1 right here, and you have 3 right here, right? And let me use another color. So at 1 we don't want to include it, so we're going to use open circle, right? And the direction of this is pointed towards to the left, so everything to the left of 1 we shade it. Okay, and for For 3, we included a 3. So we included a 3. So we have to make a dot right here, right? And everything pointed to the right. So we're going to shift everything to the right. And now we're going to write our final answer for this inequality by using interval notation and based on the graph right here. So because all mean union, okay, so we're gonna write two interval notation because union mean what? We mean we take all the shaded part. So whatever we shaded, we take it. So it will be negative infinity right here. So let me put negative infinity here, positive infinity here. Okay, so the final answer will be negative infinity, comma 1 parenthesis because this is the open circle. Union with bracket 3, right? Because if we included 3 right here, we see at 3 we have a dot, positive infinity parenthesis. Okay, so that is the way you get the final interval notation. Okay, you see, you guys really good. You look at this in algebraic expression, you can get the interval notation right away without do the graph. But I always recommend you should do the graph too. It doesn't take you a lot of time. Okay. All right. Another example. Example 2. All right. Now, so we already done all. So let's do something with n. Okay. What if I have negative 4x plus 1 greater than equal 9 and 5x plus 3 less than equal to negative 12. So because of n, so when we write interval notation, probably we have to use the upside down letter u. But let's say we have to use that or not, because n mean intersection. I mean we take just the shaded part of shade in common. So probably we have only one interval notation instead of two interval notation as we had in the first example here. Okay. Okay. So let's solve this individually. So I subtract both sides by 1, so I have negative 4x greater than equal 8, right? Then divide both sides by negative 4, and divide by negative, I flip the direction, so it's less than equal negative 2. I subtract both sides by negative 3 here, so I have 5x less than equal to negative 15. I divide it by 5, so it's less than equal to negative 3. Okay. Again, now we're gonna put it on the number line. Okay, I try to draw a very straight line, try to be perfect, even though I can't. Okay, excuse me. So you have 0 right over here, you have negative 2 right here, and you have negative 3 right here. Okay, so I'm gonna use two different color. Less than equal to negative 2, so we're going to use a purple. We're going to make the dot sign because it's included the end point. So we're going to shift everything to the left of negative 2. Okay. Now, for negative 3, again, we're going to have a dot sign at negative 3 too, and we're going to shift everything to the left of negative 3. There you go. Okay, and now we're going to take the intersection to write the interval notation. So now, do you see the part right here where the blue, this is not blue, this kind of, I don't know what color is this. I can say the blue. It's kind of green. It's not green either. So this color and the purple color is kind of overlapping each other, right? So the solution will be where these two color overlapping each other. So the interval notation for that will be negative infinity and to negative 3 bracket. Okay. All right. And there's another type of compound inequality. I want to introduce to you. For example, I have negative 2 less than equal to 5x less than to 6x, I'm sorry, 6x plus minus 1, okay, minus 1 less than equal to, okay. Alright, so this is kind of this is another type of compound inequality. Maybe some of you will ask me, well, you just say the compound inequality, we have to use the word or and over here I don't see any word or and. So I see the double linear inequality symbol here. Actually, this is an n inside, so this is the same meaning as negative 2 less than equal to 6x minus 1 and 6x minus 1 less than equal to. Okay, so you see that there's a word and right here. Okay, so in order to solve this, so this is kind of a shorter way of writing this. Okay, so in order to solve this, we can go ahead combine. We can get the x by adding both all three sides, because one side, two side, three side by 1. So adding all three sides by 1, we're gonna have 6x less than equal to 3 and greater than equal to negative 1. And now we're going to divide all three sides by 6, so we have negative 1 over 6 less than equal to x less than equal to a half, right? So 3 divided by 6 is a half. And now we can write we can have an interval notation for this. The solution will be everything between negative 1/6 and a half, and it's included. So we're gonna have a bracket negative 1 over 6 and a half. Okay, and then you can put on the number line if you want to. Okay, so it will be infinity here plus infinity here. Okay, so it's 0 right here, so negative 1 over 6 here, and 1/2 around right here. Okay, because with bracket, so it's included the both end. Okay, and whatever between there, so we're gonna check whatever between that. Okay. Okay, so that's it for compound inequality. Of course, there are so many of them. I mean, whatever I give you is just enough for you to understand the concept. You have to do a lot of homework to be exposed to a different form of compound inequality. Well, I can include fraction if I want over here. Okay. All right. So now, next part. Oops. Oh, I need to change to the green color. I'm sorry. Okay, so on the third part of our lecture, we will be discussing absolute inequality. Absolute inequality. The reason I want to talk about this after compound inequality, because when you solve absolute inequality, actually you solve compound inequality too. So you must know compound inequality first before knowing absolute inequality. And there are two formulas you need to use every time you solve absolute inequality. Okay, so the first formula is First formula is, you have to memorize it, okay? The first formula is absolute of A less than B. Less than or less than equal is kind of the same, you apply the same way. So this will be equal to negative B less than A less than B. So I'm going to box this. Make sure you memorize it. Okay. Okay. Example 1. What if I have something like this, something pretty simple? For example, I have absolute of 2x plus 1 less than equal to 5, for example. Okay. So over here you need to determine which one is A, which one is B. So you know right away this must be A, right? This must be A right here, right? And over here must be B. Right. And as long as you know which one is which one is B, you can apply the formulas. Negative B, so it could be negative 5. So I'm gonna write over here, okay? So it will be negative 5 less than equal, because it's less than equal. So if it is equal without equal, we're gonna apply the same way. So 2x plus 1 less than equal to 5. So you see over here, this is compound inequality. Right, it's kind of shorter way, right, of writing n, right? We already talked about on the second Roman part, right? So now we go ahead and solve for x. So subtract both sides by 1, so we have negative 6 less than equal to 2x less than equal to 4. I divide both sides by 2, so negative 3 less equal to x less than equal to 2. Now I can write interval notation for this without graphical representation needed. And so on the test or on the homework, they ask you for the graph, and you graph. So the interval notation will be bracket, right? Negative 3 and 2 bracket. Okay. However, not all the inequality is like this. Sometimes they add something into it. For example, they add 3x plus 4 minus 6 less than let me see, how about less than let me make up a number, something less than 8, for example. Okay. Now, if you look at the formula right here, whether you don't see anything in front of the A, right? In front of the absolute. What after the absolute, you don't have anything either. So in front of absolute, don't have anything. After the absolute, it doesn't have anything. However, in front of the absolute we have 2, and after the absolute we have minus 3. So we need to get rid of these two numbers first. So I'm gonna get rid of the negative 6 first. Okay, so I'm gonna keep this for the time being. Don't get rid of number 2 first. Get rid of this one first, the further one first. So it will be less than equal to 14. Now you need to go ahead rid of we have to rid of number 2 by divide both sides by 2. So you have 3x plus 4 less than 7. And now you see that everything now is in the form already, right? Everything now is in the form. This is your A, and this is your B. Okay, and now we can apply the formula. So this implies negative B less than 3x plus 4. Alright, less than 3x plus 4 less than 7, right? I subtract both sides by 4, so negative 11 less than 3x less than 3, and divide both sides by 3, so negative 11 over 3 less than x less than 1. And from here I can write interval notation for that easily. It will be parentheses because it's not included, and negative 11 over 3 and 1 parenthesis. There you go. Okay. Alright. Or I can add a fraction into that. Example 3. First of all, I have 2 over 3 absolute x plus 1 plus 4x less than 5%. Okay. So again, you have to get rid of this because we not allowed to have a number or anything in front of the absolute or after the absolute. And there's another way to do. You can put 2 over 3 inside the absolute bar. Say that this is one of the approach. So some students do like this. So first they get rid of 4x. Okay, they get rid of 4x by subtract both sides by 4x. So you have negative 4x plus 5. Then you multiply both sides by 3 in order to get rid of the denominator. So I multiply both sides by 3. Okay, so you cross them out. So after you multiply both sides by 3, you cross them out, you're gonna have this, right? Okay, I distribute the 3 in, so negative 12x plus 15. Then there's two ways to get rid of 2. You can put into the absolute bar, or you can go ahead divide both sides by 2. I think I'm going to put everything into the absolute bar, so yeah, I'm going to put 2x plus 2. You can call it distribution. So basically you distribute in here, but it's not distribution because we don't have distribution for absolute value. Okay, so negative 12x plus 15. Now let's see you can solve this or not. Now absolute of A less than B, so this is your B right here. Let me see if we can do this or not. Because probably you can't do this. So let's continue. So let's see what happened. Okay, let's see what happened. So your B will be this, your A will be this, right? So this is your A and this is your B right here, right? So you have negative B, so negative B will be negative of negative 12x plus 15 less than B less than A less than B. Alright, so how are we going to solve this? Of course, it's very hard to solve right here. It's very hard to solve directly from here, so it's good that you go ahead and split them up by using n. So this is the same as negative of negative 12x plus 15 less than 2x plus 2 and 2x plus 2 less than negative 12x plus 15. Okay, so I'm going to distribute the minus in, so I'm going to have what? I'm going to have 12x minus 15 less than 2x plus 2, right? And over here I will add both sides by 12x, so I have 14x plus 2 less than 15, right? And I subtract both sides by 2x, so I have 10x minus 15 less than 2. Add both sides by 15, so I have 10x less than 17, right? And divide both sides by 10, so I have 17 over 10. I subtract both sides by 2 over here, so I have 14x minus 13. Divide both sides by 14, so I have 13 over 14. Okay, good. Oh, now we can write interval notation for this, but you have to be careful. This is n, so I recommend that you go ahead draw the number line in order to get the final interval notation. So it's negative infinity here, positive infinity here, so 0 right here. 17 over 10 is about 1.7, so 17 over 10 here. 13 over 14 is less than 0. Oh, I'm sorry, it's not. It's greater than 0, I'm sorry. Oops, let me redraw that. It's greater than 0, so it's about right over here. So 13 over 14. Alright, let's shade it. So we want less than 13 over 14, so we have open circle, right? So less than it will be right here. Alright, and we have less than 17 over 14, so this is also open circle, and we're going to set everything here. Okay. Now, where is the part where is the part is overlapping? Because N is for intersection, so we take the part of overlapping. So from here, right? From here, right? But you have to be careful. At 17 over 14. At 17 over 14, we don't include it. And when you draw the green line, we just we basically we basically cover 13 over 14 once, not twice. Okay, so the interval notation for this will be negative infinity and 13 over 14 parentheses. Okay, parentheses, and that's it. So you see that in this, for this compound inequality, you cannot solve directly. It's not like last time. Let me go back to the last one. So it's like last time, you know, you see over here, you can solve directly from the original one, but for this one, you have to split up into two. Okay, so you have to be flexible. Okay, sometimes you have to split up into two, sometimes you keep it like that. Okay, so that is this is the first formula. So now we're gonna do the second formula. The first formula is for less than. Now the second formula is for greater than. Absolute of A greater than equal B. Then this is implied A less than equal to negative B, or A greater than equal B. Please, you have to memorize this too. Okay. Alright, so let's go through the example. Example 1. Okay. What if I have this? 3 minus 4, or 3 plus 4 x plus 1 greater than 50. Okay, so you look at this, you see that you have to get rid of 3 and 4, right? Because you're not allowed to have anything in front of the absolute. So we need to get rid of 3 and 4. So we have to get rid of the further one first. So you have 4x plus 1. You're going to subtract both sides by 3. Subtract both sides by 3, so have greater than 12. Then excuse me. Then you divide both sides by 4, so we have x plus 1 greater than 3. And now you're going to apply the formula. So this is your A, this is your B. Okay. Now you apply the formula, so A So this is imply what? A less than negative 3, so will be x plus 1 less than equal to negative 3, or x plus 1 greater than equal to 3. And you're going to solve for that. So x less than negative 4 and x greater than equal 2. And from here, well, if you draw the number line, you see that it's not going to be overlapping each other, because it's negative 4 on the left hand side, 2 is on the right hand side of 0. So you can write interval notation right away, negative infinity to negative 4 bracket, union with, because it's or, bracket 2 to positive infinity. Okay. Okay. All right. Let's do another example. Example 2. How about this? Well, how about I have 2/3 x minus 3 plus 5 greater than 9, greater than 9x. Okay, again we need to get rid of 5, we need to get rid of 2/3. So I'm going to keep it for the time being, subtract both sides by 5, so I have 9x minus 5. So I'm going to multiply both sides by 3. So I'm going to write over here, okay? So I multiply both sides by 3. Okay, across this. So I will have 2x minus 3 greater than 27x minus 15. Okay. Now again, I can put 2 inside the absolute value, so it becomes 2x minus 6 greater than 27x minus 15. Okay, so this is your A. This is your A, and this will be your B. Okay. Then we can apply the formula now. Absolute of A greater than B, so it will be A less than equal to negative B, kind of big number, or A greater than equal to B. Now we're going to solve it separately. So 2x minus 6 less than negative 27x plus 15. So add both sides by 6, so I have 2x greater than 27x minus 9. Add both sides by 27x here, so we have 29x minus 6 less than 15. Add both sides by 6, so we have 29x less than 21. X will be less than or equal to 21 over 29. I subtract both sides by 27, so I have negative 25x greater than negative 9. Divide both sides by negative number, so I flip it, so it becomes 9 over 25. So right now you see that it's less than and less than, so it's good that you go ahead draw the number line so that you see the part. You're gonna take everything though, but again, because it's or, but it's good that you go ahead and grab it. So 9 over 25 and 21 over 29, you have to see which one is bigger. So let me do a quick calculation. 21 over 29 is 0.7 and 9 over 25 is 0.3. So 9 over 25 is kind of smaller, so you have 0 here, and 9 over 25 here, and 21 over 29 right here. Of course, both of them we're going to use dot. So less than, right? So we're going to set everything here. Now let's use another. So I'm going to use, let's see what color I should use. So I'm going to use this. So this again, I'm going to, oh, this is not good color. So let me use this. Here you go. Well, this is kind of not good either. So let me use the blue. This is better. Here you go. Less than, right? So I'm going to shade it too. So I'm going to shade it. So now, because this is all, right? And all, what is all mean? All, we're going to take everything. All the part we shed, we have to take it. But of course, we just take it once, okay? One time. So you see, every part over here we shed, and all the green, all the purple part over here we shed. But because it's overlapping over here, so basically we just write 1. So our final answer will be negative infinity 21 over 29 bracket. Okay. All right. Okay. So again, you have to do a lot more to get used to. Now the last part of our lecture today. I will be talking about absolute equation. And when you solve this, when you solve absolute equation, there's also 2 formulas you should memorize too. Okay. The first formula is absolute of A equal B. If absolute of A equal B, then it's implied A equal plus or minus B. Okay. And the second formula is, I think we're going to do over here too. The second formula is absolute of A equal absolute of B. This is also implied A equal plus minus B. Okay. Now let's do one example for the first formula. Okay. What if I have this? Negative 2 plus absolute of 3x plus 1 equal x. Well, you recognize right away this is A. However, see again in front of the A and after the A, there's nothing, and there's nothing after the in front of the absolute and behind the absolute. So, but we get stuck with this, so we need to get rid of negative 2. So in order to get rid of negative 2, you add both sides by 2. And now everything become A and B for you. Alright, now just go ahead. We're going to split up into 2 guys. So A equal B and A equal negative. Okay, because right now we solve the equation, you don't have to worry too much about inequality. In the direction will be equal to 1, right? So x equal half. Over here you have 3x plus 1 equal negative x minus 2. So you have 4x equal to negative 3. X equal negative 3 over 4. Alright, again you have to check if this is solution or not. Okay, so it's your job to plug them back and to see if it satisfies the inequality or not. Okay, because sometimes if it does not satisfy, then you will have no solution. Okay, alright. Now let me give you so this is your job to check. Yeah, so no, I'm not gonna check it for you. So I'm going to give you example for this case. What if I have something that's just, this is very easy one, so I will have 2 minus 3x equal x plus 3, for example. So you know right away this a and b, so you just go ahead and split it up into two cases. Alright, so you're gonna have 2 minus 3x equal x plus 3, and 2 minus 3x equal minus x plus 3. So we're going to solve for this. I subtract both sides, so negative 4x. I subtract both sides by 2, so 1. So x equal negative 1 over 4. Distributed. That's negative 3. So I have negative 2x equal to negative 3 minus 2, negative 5. So x equal 5 over 2. So again, you have to check if this is correct answer or not. You gotta plug them in, plug into the x, and see, plug negative 1, 4 into here, negative 1, 4 over here, and see that it equal each other or not. Plug 5 over 2 here, 5 over 2 here to see if it is equal or not. If it does not equal, then it's no solution. If it equal, then it is solution. Now get back to the first form. Let me give you another example. Okay. Let me see. We can have something kind of fun. What if I have 2 over 3, 1 minus x minus 4 equal x plus 5. Okay. Alright, so I'm going to get rid of negative 4 first by adding both sides by 4. So I have 2 over 3, 1 minus x. Okay. Add both sides by 4, so x plus 9. I'm going to multiply both sides by 3. So I multiply both sides by 3, so I have 2 over 3 multiply both sides by 3. Okay, so cancel this, so I have 2, 1 minus x equal 3x plus 27. Now I'm gonna put 2 into the absolute bar, so I kind of distribute it. Alright, now here you go. I have A and B. So this is your A, this is your B. Now you can split it up into 2k. So you're gonna have 2 minus 2x equal 3x plus 27, and 2 minus 2x equal negative 3x plus 27. And you're going to solve for this. So negative 5x, subtract both sides by 3x. Then subtract both sides by 2, so 25. So x equal to negative 5. Distributed. Alright, minus 27. Add both sides by 3, so you have x equal to, subtract both sides by 2, so you have negative 29. Again, you go ahead and plug it in to check. Okay, plug negative 5 in here, plug negative 5 in here. If it equal, then that's solution. If it does not equal, then it's not the solution. Okay. Example 2 for this case. Alright. What if I have this 4/5 x plus 1 equal 2, 3 x minus 4. Okay. So right now you see that we're still getting stuck with the fraction in front of the absolute. So in order to bring it back to the for absolute of a equal to absolute b, you gotta put everything inside the absolute. So we have 4/5 x plus 4/5. So if you do like this, okay, if you do like this, 2 times negative 4, negative 8, 3, right? So if you do like this, you see that you have to deal with fraction. So I recommend that don't do this way. Okay, don't do this way. Alright, so this is what I'm gonna do. I'm gonna multiply both sides by 15 because you see the LCD over here is 5, 3 is 15. LC least common multiple is 15. So I'm going to multiply both sides by 15. So I have 15 4 over 5 x plus 1, and over here 15 2 over 3 x minus 4. Then you see 15 divided by 5 is 3. So 3 times 4 x plus 1. Over here 15 divided by 3 is 5 times 2 x minus 4. Then you multiply, it will be 12 x plus 1 and 10 x minus 4. Then now you're going to put into the absolute. You see that you try to get rid of the fraction. Now you just dealing with whole number. So you have 12x plus 12 equal 10x minus 40. It's kind of big number, but now you can split up. So 12x plus 12 equal 10x plus minus 40, and 12x plus 12 equal negative 10x minus 40. Okay, now subtract both sides by 10x, so you have 2x. Subtract both sides by 12, so 40 minus 12 is 28, right? Yep, 28. So divide both sides by 2 give you 14. 40 minus 12, negative 14. No, so it's not 28. I'm sorry. It should be minus 52. Okay. Now 52 divided by 2 is 26, right? Negative 26. And over here, 12x plus 12 is minus 10x plus 40, and both sides by 10, so you have 22x. Subtract both sides by 12, so 40 minus 12 is that 18? No, it's 28. Right, 28, right? Because 10 over here, 10, 28, right? So 28 divided by 22, no, that's not going to, but again, we can simplify, so it will be 14 over 11. Again, you gotta check if this is solution or not by plugging it in, okay? Okay, I'm not checking for you, so you can plug negative 26 over here, 26 over here, negative 26 here. Then you check it if it equal, plug in 14 over 11 here, 14 over 11, let's see if it equal or not. Okay, because sometimes it's not the solution. So let me put this is your A. Okay. Alright, so I think that's for section 2.7. If you have any question, please let me know. Please keep up with your homework. Okay, see you next time.